Hi guys, thanks for joining us. I'm Caitlin with Test Equipment Depot. Thank you for Megger for bringing us this presentation today on testing and qualifying the telecom power grid and the multifunction tester 70. And now over to Tony Wilson.
Well, thanks, Caitlin, and thanks to our partners at Test Equipment Depot for sponsoring this webinar. Today, we're going to be talking about the MFT70 multifunctional tester. This is a very compact unit that is built to do all the testing that is normally done by 3 separate test sets. And the good news is it all comes in one compact package. You can do your continuity testing, you can do your resistance testing, GFI testing, and also it is a 2 or 3 pole ground test unit. So it is a total system, all packaged in a compact footprint. And we can talk about all the different features, but this test set was designed primarily to test the low voltage electrical connections that are used in the telecom systems today to be in compliance with the NEC as well as ATIS standards for telecommunications. So let's talk about this test set, why it's necessary, and what it may do for you that you haven't had the opportunity to use before. So here's just an example of an application for the telecom systems. You know, we have both wire and wireless when you talk about telecom. You can look at all the different access points that are there within this system. It gives you opportunity to test for grounds, which are critical in some of the new telecom applications, as well as for insulation resistance and continuity. So all those applications and the ability to perform those tests are all contained within the MFT70. So when we talk about the MFT70 and its test capabilities and what it was designed for, we talk about a thing called the telecom power grid. So what exactly is that? Well, if you're a local exchange carrier, that is your existing network, the twisted copper pair that has been used for data and communications for, well, decades. If you're a new third-party provider or you're a contractor who's building out for a third party, you might be talking about a new existing power node, so you might be creating a telecom power grid. But in simplest forms, it is a twisted copper plant that goes from a central power source out to a load location. So when we take a look at that for the standard network, it would look like a central location, which would be referred to as a central office in telecom vernacular. It might be an MSO. If you're an MSO, it would be a head end. So in any rate, it really boils down to getting your single source of commercial power, converting it to a 48 volt DC via a rectifier. And then in this case, for the telecom power grid, instead of using that 48 volt supply for communications and data, we're going to convert that to a high voltage plus minus 190, and that's to give us distance. So if you started out with 48 volts and tried to go long distances, your voltage drop would make it unusable power. By bumping this up via DC-DC converter, it actually allows us to take this and supply power to load locations, whether it be surveillance cameras, traffic lights, traffic signals, D-slams, or small cells. All those applications, it doesn't make any difference as long as it utilizes the standard voltages provided, which are 48, 24, and 12 volt. So if you have a standard network, you would start at the central office, go to the load location. If you were creating a telecom power grid or extending your telecom power grid, you start out with this power node where we're actually duplicating what was taking place here in the central location. We're taking an AC input source, converting it to DC, and then transmitting it over lines, either going to a small cell, to an ONT, or to a power node. Make sense? So in this case, there was no power grid available. So we're showing the creation or extension of a power grid via a hybrid cable. And this is kind of the new frontier for driving fiber deeper in the network without reliance upon a third-party commercial power. This hybrid cable contains not only the fiber for your communications and data in the outer core, but in the inner core, there is a number of twisted copper pairs. In this case, there are 25, it can be 50 or 100, depending on your needs. And all of your power is going to be delivered from your central power location here out to your location here. Make sense? This is the, I called it the new advent of the telecom age, is the use of hybrid cable. So what is this about, remote line powering? Well, remote line powering has been around for a long time. But in this case, what we're doing is converting some of those vacant pairs, and there are a lot of them, by the way, that have been used for data and communication. And because of the bandwidth requirement, copper is no longer able to deliver those speeds that we need to be effective in our work today. So what we're doing is we're transforming this power, this cable, in from a communications cable, and we're repurposing it as a power cable. And line powering is enabling us to do this. So what we're doing is energizing a conventional 48 volt DC supply to a plus minus 190. And as I said before, we're doing it to extend the reach over the copper cable. So in instances, we can power a DSLAM or a small cell from up to 5 miles away from the power source. Because we have multiple pairs within this cable, then we're able to power multiple units. So instead of having a single power source at each location, one cable can supply up to 8 nodes. This is what makes the MFT70 so necessary at this point, because we're testing multiple copper pairs at levels that heretofore were not necessary. Before, we had 48 volt and maybe plus and minus 130. But as I said, we've gone to plus minus 190. That gives us the safety standard, but gives us additional reach. And the capability of the MFT70 is critical in this stage, because your standard MFTs that are in the field today are not designed to test at this level. Make sense? So this is just a pictorial evidence of what I just talked about. We're taking a single source of AC. Yes, we still have to have commercial AC, but we're only using one source. We're converting it to DC one time, and then we're sending it out over multiple copper pairs. And this is important because the MFT70 is going to qualify those pairs for us to make sure that they have the integrity to maintain a nominal load of 380 volts. To do this, we're going to have to stress or test these pairs at a 500 volt range, which is beyond the capabilities of most test sets. Okay? What's causing this need for speed or need for more power? Well, time is of the essence. I had an old boss one time that told me, had a saying, speed kills, especially if you move too slow. Well, the competitive nature of the telecom network today means that we have to be able to deliver these speeds, deliver this bandwidth on demand, quicker, faster, better than all of our competition, whether it be in the wireline or wireless industry. What we're doing is we're having to push fiber deeper into the network, because fiber is what will allow us to reach those speeds. Remember, copper has a limitation of delivering speeds of 100 meg, which is required if you have distances of more than 1,500 feet. So this is critical. So when you're placing the fiber in the network, you have to have power. If you want multiple sources of power, what better way to do it than to deliver your power and your fiber in the same sheath? There's a lot of issues in this powering, this explosion of the telecom network. First of all, conventional power solutions aren't always on your timetable. They're capital expensive because you have to go ahead and do your planning. You have to do a lot of permitting. There's a lot of things that are thrown into this that cause it to be time and capital expensive. Deployment schedules. If you can't get it in when you need it, what good is it? And it's there for you to manage the electrical utilities locations. And the analogy I use is I've got power everywhere in my house, but for some reason, my wife will decide she wants to move the TV to the other side of the room. Unfortunately, I don't have a plug there. So even though I have power available, it's not available where I need it. Well, this is what's driving, and one of the primary drivers for the telecom power grid, and also a primary driver for the need for a test set like the MFT70. In fact, it's critical that you have a test set with this capability for you to be able to qualify, not simply quantify what you have, but you have to qualify the network that you're going to be using. Make sense? The one takeaway from this is when we're talking about the advent of fiber in the fiber world, you need to remember that copper still has a useful life. If you're an LEC that's out there that has a copper network, all those thousands of pairs that are vacant, have been lying there and not being utilized, are simply waiting for you to utilize those to provide power either for yourself or maybe to generate revenue via a third-party source. So don't abandon that copper, simply take it, qualify it using the MFT70. You'll be able to repurpose those pairs for utilization as a power network instead of a communications network. And don't forget, utilizing this cable for what we consider non-traditional telecom applications is something that's really catching the attention of many of the players in the telecom network. And again, if you don't already have a telecom power grid or a copper cable in the area, you can bridge that gap utilizing a hybrid cable. So here's a typical example of one of the advantages of utilizing the telecom power grid and having a qualified telecom power grid via the MFT70. You have a strand mount application, you have a cabinet in the middle, and I want you to note, we're placing our power source in the middle of our span. So we can power bidirectionally, but our feedback to our fiber switch is via our pure fiber. In this case, we're setting a cabinet and we're using a hybrid cable to carry that, bridge that power and communications. So we have a need for a power source here as well as communications. This is an aerial application. There's also buried and underground. In all these cases, there is a need for a test set that can test and qualify the ground for this cabinet, the insulation resistance value of each of the copper pairs, grounding here at the strand, as well as continuity for all the system. So you can see the value of having one test set that's going to do all these things instead of carrying multiple test sets. Make sense? Well, we didn't get here by accident as the Megger Corporation. They picked out one of the leaders in the industry. Enersys Alpha at this time was leading the industry and still is, to my knowledge, in the delivery of line power systems. They were approached about having a test set that would actually qualify a pair because our customers were utilizing test sets that were limited in their scope, up to 150 volts. They really didn't have anything out there that not only would give them the insulation resistance value they needed, they didn't have anything that would actually stress the pair above that 380 volts. So great partnerships are built on need and reliance, and thus the need to test the cable at levels that were heretofore not needed brought forth the best in development out of Megger, and the MFT70 was created. You're going to see some features of this, but it takes you through all the areas that I was just talking about. It goes through the area of voltage, because we always want to know about our voltage, right? It goes through our ground fault interface. It does our insulation resistance testing, and it's going to do our continuity testing and ground testing. So everything that you need to qualify a line power, remote power, span power system is going to be contained within this one little unit. Compact, efficient, and complete. So let's take a look at this, and I'll apologize in advance because it gets a little busy because There's just a lot of features to this little test set. When you look at the first thing you notice is there's a test button on either side. So for you lefties out there who are always trying to reach across, you should like this a lot. This is a convenience because sometimes you're in a cramped area, you're by yourself, you're trying to hold leads in place. We solved that problem with this test set as well. But again, you've got a test set button or a test button on both sides. You have a lock button to lock in your test results. You have a menu control key. You know that and the setup key on this are great, but I'm telling you, you have two selector knobs here, and going through a lot of setup is one of the great things that you avoid in utilizing this test set. So you just simply set it to what value you're looking for, whether it be voltage or a separate knob for your ground resistance information, but you can go through everything you need just by following this and some of the guides that are set up in the quick start guide. You got a rubber molding around this to make sure it's durable. The test lead connector is conveniently located on top because sometimes trying to reach around behind where you can't see in a tight situation is very, very difficult. Backlight. How many times have we been out there where you know you got your test leads hooked up, you know you're getting a reading, you just can't see the darn thing because the sunlight's so bright and you don't have a good backlight control that allows your screen to be visible. Again, your display, storage, and communications. You know, if you're only testing one pair or testing one ground, not a big deal, but we're into the new advent that we're going to be testing tens and hundreds of pairs and qualifying them to this new standard. So we want to be able to store this information easily, quickly, either within this test set or into a compatible device through a file download manager. Make sense? So again, we do installation continuity. We have ground test functions, again, on the GFI test function, which is unique. And one that I'll be talking about at the very last, which is not available to my knowledge with all these other features on any other test set, is this non-touch volt detector. And this is a highly, highly advantageous safety measure that is on this test set. So what's the nice thing and what's the best thing about a unit? Well, one of the first criteria to a unit, if it's not easy to use, you're either not going to use it or you're not going to use it effectively. This is very compact. You can see the Craftsman has it around his neck. It's lightweight, high visibility screen. He can set it quickly with either one of those buttons. It has rechargeable batteries. And again, you can go to all those options without going into setup. And the auto start tests are just for ease of use. We talked about this briefly, but data storage, I can't overemphasize this. Being able to store your information, you're going to be testing multiple pairs, multiple grounds. So when you have a project or you have a deployment and you want to have all the information with a timestamp date, so you know the condition of that cable, that date, when you turn it over, it's good. You know it's good, it's qualified, you can point to that. Again, here we have with ground testing, either 2, 3 pole or the attached rod technique. So you can do all of these with the additional clamp-ons and have a complete test set that does not only continuity, GFI, the insulation resistance, or you can do the ground testing as well. Well, stop carrying multiple test sets, and we say that at Megger, even though you may be carrying 3 of our test sets, we want to make this convenient for you. So it's very important that you get to the point where you can do all of your testing only utilizing one instrument. And with the MFT70, you can do it with ease. So again, carrying one test set, it not only allows you to qualify the cable, you can do it with one test set instead of 3, and you can still perform functions that you couldn't with some of the others. Well, what's in the box? Well, there's a lot in the box. There's the test leads, the clip-ons. You can do clamps, get additional clamps, everything you need for voltage testing, ground testing, and qualifying the cable are all contained within this box. Well, some of us don't do the same test every day. And yeah, I forget occasionally, and I bet you do too. So if you need a quick crash course or refresher as to how to run these tests, everything is provided in our quick start guide that comes with the set. Talk about measuring voltage, and we talk about voltage first because it is important. First of all, we're looking for voltages that we haven't seen before, and we're also looking for some maybe stray or strange voltages that aren't supposed to be there. So when you're measuring voltage, it's very, very easy to do. You simply set your test set to a voltage setting, you connect your leads, and you run your test. Easy as 1, 2, 3, right? We run a test for voltage on this. We're looking for both alternating and direct current voltage. Now, this is in the guide that we showed you from Intersys Alpha, and this is also in the same guide that comes from ATIS and from the NEC code. The first thing you want to look for when you're testing a cable is the voltages on that cable. Hopefully, you're testing on a vacant pair. If you are, you'll be testing and finding, hopefully, little or no voltage, but we set parameters on this that tells you a go, no-go system. So if you're looking for alternating or AC current and you hook up to a vacant pair, if you're under 10 volts, and I'd like to be less than that, but if you're under 10 by the guidelines, you're good to go. So you can go to the next test. If you're over 10 volts AC, you should stop the test, and you got to find out where that fault is in that pair that's allowing that leakage or that voltage to be on that pair. Same with DC current. If you're over 3 volts DC, it means you got a pair that's crossed or a pair that's shorted because you're seeing voltage overlap from another pair or from another source. In any case, whether it's tip to ring, ring to ground, or tip to ground, it is a go, no-go system. It tells you when to proceed, when to stop. But all 3 of these tests are critical to run if you're going to qualify the telecom power grid. Storing test results. I guess you think I'm beating a dead horse on this, but I'm telling you, when there's 2 of you working together and you're crossing MDF, you want to be able to take those results. You don't want to be telling someone what to write down, hoping you wrote down the right pair and the right measurement. You want to be able to store that information directly in this test set. And it is easy as 1, 2, 3, 4, 5. And again, having those test buttons on either side of the equipment comes in very handy in this operation. So as you run through the storage of the test set, you're able to do everything that you need, and you can store it directly into the MFT or download it to a compatible running device using the Megger Download Manager. Make sense? Good. Measuring continuity. Well, measuring continuity is pretty easy. Just make sure that you press the leads together to null out the test set. Once the null symbol shows, you can proceed with your test. And once you hook it up, the test runs on its own. It is a hands-free test at that point, but be sure you do null the test set before you begin. Insulation resistance is something that you hear about. We have a high value that we set for the qualification of the telecom power grid. Remember, we're running 380 volts. We're going to be running an insulation resistance test at 500 volts between tip and ring because we're looking at the relationship between the pair. And then it's going to be 250 volts, as we're seeing here on this particular measurement, between tip and ground and ring and ground. So we're looking at the relationship between the tip and ring, or L1, L2, relationship between each side of the pair to a ground reference or to a shield. Make sense? But I want you to look at the arc that you have on this. Not only do you have a digital readout, you have an analog simulation scale that tells you a little bit about the testing of this pair. In this case, you're seeing a pair being tested. It's going out at a pretty good distance. It's recharging the cable, and it goes from 18.9 meg to 50 gig ohm. So we've exceeded that 100 meg ohm reading by a lot. This is a very, very good pair. But again, utilizing the capabilities of this test equipment, it shows you not only the digital readout, but it shows you the behavior of the test, which is very important information. Again, when you measure for that, you want to set your insulation resistance. Remember, we're talking about the 500 volt range. Once you get the insulation resistance set at that, you're hooking your tip ring to your L1, L2. You're pressing your buttons, and then you're going to watch the arc and the behavior of that needle, as well as getting your digital readout. Okay. Well, the great thing is if you go with a two clamp stakeless test, you can do your ground resistance testing. And this set, just because the industry has had a lot of different ground test devices out there, Megger has actually led the industry in this particular field for years. So it makes real quick work of a 3-pole test result. Okay. If you're looking at your ground resistance, you can utilize the 2 clamps for the MFT70. It becomes a functioning clamp-on ground tester, and once again eliminates another test or another test set for the technician to carry. You've got your insulation resistance, your ground resistance, and your continuity testing all rolled into one test set. So you have 2-pole ground resistance. If you're in a hurry and you need to do a quick check on ground resistance or check on an existing ground source like a cold water pipe, the MFT70 can do it in just a very simple 2-pole testing mode. And you're done. Not only do you have the 2-pole capability, but you also have the 3-pole capability. Again, running this test with the additional clamps makes this simple and easy work. This is one for the 3-pole attached rod technique, or what we call ART. This is something that is unique within this particular test set. You can take the additional clamp and make a quick work of a ground resistance test. And if those thermal wells are part of your daily routine, this is going to make your life a lot easier. Well, a lot of times we're out and we're on not a nice dirt surface. We're out on asphalt or concrete, and we're still trying to get a good ground resistance reading. So how do we do that? Well, like all good recipes, sometimes you just add water. And that's what you do with this. If you lay the stakes on their sides, making contact with the concrete, just pour water on it to enhance the reading. You will get a reading otherwise, but this simply enhances the reading of the test set. I told you I was going to do one last thing and make this my last slide to talk about features. This particular feature is the check for touch voltage. This gives you the ability to identify potential hazardous voltage. And it's done very, very simply. I call it a good site reference check. You take the single rod or the one lead, and you touch it to a metallic surface while placing your finger on the indicated area on the test set. This will identify potential hazardous voltage before you enter an enclosure. So while it may not be the pair that you're working on, but you just want to check site safety around you, this is a very, very important and a great feature to add to the MFT70. Remember, the Megger MFT70 is designed for qualifying the telecom power grid. There is not another test equipment that does all of these tests, has all of these features, the compact size, it's compact, it's versatile, it's convenient. Hey, I thank again, Caitlin and our friends at Test Equipment Depot. Thank you so much for your time. If you have questions, we're ready to take them that time, or you can contact your Megger representative. Thanks very much and have a great day.
Thanks, Tony. For more information on the Megger MFT70 multifunction tester, visit the link below.